Our given in this problem is grams of cadmium perchromate, and it's 81.6 grams of cadmium perchromate. And my unknown, or what I'm trying to get to, is number of molecules. And so I put molecules at the end of this diagram. Now, theoretically, I would love to have a fraction that gets me from grams to molecules. But when I go up here, I have nothing that gets me from grams to molecules. The only one that I even have that has grams in it is this number 2 on bottom. Their number 1 has grams, but it's not on bottom. So I don't have something that gets me to the molecule part. I'm going to have to use 2 fractions in this case. So the first fraction I'm going to use is number 2. The molar mass is going to go on the bottom, and on top is going to be 1 mole. So when I go back down here, I'm going to use the molar mass, which is given in this problem, and I'm going to write it in a fraction. I know that the 228.4 goes with the grams, because that's how many grams there are per 1 mole. Now I have to erase this unit because that fraction is for 1 mole, not molecules. Now I'm in the units. When I look at my units, the grams cancel, but I'm left with moles. I'm trying to get to molecules though. So I would like to be able to convert from moles to molecules. And if I go to the very top, I can see that there is a fraction where moles is on bottom and molecules is on top. And that's fraction number 3. I'm going to use Avogadro's number to convert from moles to molecules. So I go down here and I'm going to type in, or write in, that 1 mole is equal to 6.02 times 10 to the 23rd. And if you notice, I'm saying equal to. Anytime I have one of these 4 fractions from up above, they're all equal to each other, meaning the top is equal to the bottom. And you might not have noticed, but all of these fractions are equal to 1. The reason is if the top is equal to the bottom, let's say x divided by x, well, x goes into itself 1 time. So the only way that this system of converting works is if you use equalities where the top is equal to the bottom. They're called unit conversions. So when you do this, the math on this, everything on top is going to be multiplied by each other, and you're going to divide by what's on bottom. So if you're just thinking in terms of what you're going to put in the calculator, you're going to put 81.6, and then you're going to multiply it by 6.02 times 10 to the 23rd. And since the 228.4 is on the bottom, that means we're going to divide by it. Now it's a good habit to use your parentheses correctly. I'm misleading on how I'm showing them up here. You probably want to put the parentheses like this. In this case, it won't make a difference in your calculator, but it's a good habit to get into. So that makes your answer 2.15 times 10 to the 23rd when you do the math. Now, I'm going to do this problem with the circles. Doing this with the circles, you can do this in 2 steps. The 2 circles we're going to use, the only 2 in this unit, it's just the matter of the order that you're going to use them. If you put your given in, 81.6 grams, and your molecular weight in, 228.4, but that's not what you're trying to solve for. You're trying to solve for molecules, which is over here on this circle. The only way you can solve for for molecules is if you have moles. And the only way that you can get moles is by getting an answer over here. So you take your answer and you put it in this circle. The way you get your answer to this section right here is by taking grams divided by molecular weight. You get that answer and you put it over here. And since it's right next to Avogadro's number, you're going to multiply. It ends up being the same math as what you would have done on the dimensional analysis. It's just another way to do these problems.